So we're here to talk through this star battle puzzle from Serkan. The small regions variation highlights a step that's very common in star battles, which is to look for cells that have shaded, the cells that if they were a star would eliminate all potential options from an adjacent group. So if this is a star, you can't place a star in that region, so it can be eliminated. And while it won't be so critical in this puzzle to mark all such places, this is a kind of bookkeeping step that's often done at the start of these, and in the easier puzzles this week was sufficient to actually get all the way through. The reason I wanted to highlight this puzzle is it actually uses one of the more challenging kinds of deductions in star battle puzzles, but actually highlights a way to recognize these deductions much easier, and that has to do with region counting or star counting in general. I think that constructors of star battle puzzles know how to spot this deduction better than solvers do, and some of it is the solvers kind of don't know where to look. So I want to kind of teach you where to look. And so, how does a solver stumble into this sort of thing? Well, here's a kind of convoluted way, but one that people will sometimes see. Like, at the top of this puzzle, there's a pretty stark sign that we have 3 of the stars that will be in the top 2 rows identified. And if we look around, we're like, do I have a limit to where a 4th star will go? And it seems maybe, there's a star down here, so there'll be a star up here. And so I have 1, 2, 3, 4 stars in the top, so I can come over this way. This is a star here, there's a star here, sort of eliminate out this. And that's a very hard way to get a deduction. That's actually much easier if you look for a certain kind of visual cue. And what I look for is a lot of bold boundaries on any row or column. So if I'm just looking across all of the rows, my eyes stop at these 2 spots, and if I'm looking in the columns, my eyes stop at this spot. And let's sort of see what happens if we focus on those spots. So in this case, with this division, we have 2 cells that stick up and 2 cells that stick down. In some puzzles, it will be the case that both of these get filled or both of them get left empty, but there's something about an in and out that's true in this division. On this one on the right, it's actually the case that we only have 2 cells that stick to the left. So what you do when you isolate these spots is just count the regions and think through the consequences. And in this case, we have 8 regions that touch above this line, 6 of them that are wholly above the line, and so the consequence we already got to in a harder way is all these cells on the other side of the line can't be used. In this case, we have 7 regions, which means that at least exactly one star is to the left of this line in these spots. We've already marked off this cell, so the star that must be used is here. And I'll just mark all this off. And the last case, again, this last row 4 from the bottom, it has 3 cells that stick up from the line. At the very start of the puzzle, we could have counted and seen there are 9 regions down here, which means one of these 3 cells is a star. Because we've now marked off these 2 as options by region counting, we can get that cell right there as a star. And so this concept of at least marking interesting boundaries is something that, if you get used to seeing it this way, you'll more naturally recognize where the star counts are heavy or the star counts are light. That's a way of saying that you'll know where you need to move a star over a boundary or keep a star from crossing a boundary. We'll get to this state of the puzzle. We didn't mark off these cells, so I'll do it now. Get to a spot like this. Something that's often helpful is to be marking cells that have to be in a particular vertical or horizontal space, so we know a star is in this column. We have a second star in this column, and forces these over. We're kind of in a situation here where we want to resolve something about these regions. We have 3 stars. This will have a 4th and a 5th, and we don't know if the 6th is in this or in the S. But something that we've now placed is another star on the left, which we hadn't sort of looked at regions on the left side, but now sets up this side to be better. You could have at the start said that the third column or fourth column are okay to look at in this way. There are actually a whole lot of regions that sit across the third column, but there are a total of, after we've marked this star, there are a total of 5 that must be to the left, so there'll only be one more star, and that star can come into this region or that cell. On the fourth boundary, we have a similar situation. Before we've marked this star, we have 1, 2, 3, 4, 5, 6, 7 that have to be there, and then we get an 8th, which will be in these cells, here, here, here. We've actually done a lot more deductions in the grid. We've actually placed the 8 stars. So if we looked at this more suspect boundary now, we see you have 1, 2, 3, 4, 5, 6, 7, 8 that are fully over. So this cell here can't be used. These 3 cells can't be used. We get now to a state, if you've marked all this information in the grid, we're going to get a quick cascade of placements. It'll start by seeing we filled that row, so we put in this star. That fills this row. Place a star there. We get a star in these spots. This column has 2 options left for its last star. We've actually placed the stars in that spot. We have 3 in the bottom. This will be a 4th. Might as well mark it. So we can cancel off these. This row has 2 stars. Now it has this 2 stars, 2 stars. What we can next deduce is actually there's a star in one of these cells. It puts a star up here, finishes out this space. The star, sorry, I guess I missed this. When I place this star, I can force this below. That forces this up, this up. That completes this column. Get to here. The last steps in the middle are a little bit more removed, but I think they all eventually come together by thinking about the S and where the star gets in the S. This cell is eliminated because it can't be one of these. It would get rid of all these options. This option in the third cell actually is a consequence of placing stars in these 2 spots, and that would be a total of 3 in this column. So you end up with a case where you have a star will be in one of these sides. The thing to recognize is we do have to get a sufficient number of stars in the different columns, and the way we can deal with this is to actually see of these 2 stars, one of them has to be in the second row, and so a spot like this, if it were shaded, would force everything up. After we've marked that as unused, there's only these 2 spots for a cell remaining in this column, and that eliminates this option from the S. And so the final step is a little bit of looking across different regions to get to it, but there's a nice end to a somewhat challenging puzzle. Hopefully you learned, at least in this walkthrough, something about how to see some borders that may be key to do region counting in. That's a lesson you can apply to even regular star battle puzzles, although it's sometimes a little more subtle, but often you'll have just a few cells sticking out of a region, a few cells sticking in the other direction, and when you actually do the proper counting, you may see it you need to fill or leave empty those spaces. So this puzzle that actually used it first on the top, and then on the right, and then on the bottom, and then finally on the left side actually used this one deduction quite often, and that's why we highlighted this in the walkthrough. We'll see you again soon.